Okay, I guess we can start. Again, welcome everyone to this breakout session. I'm Vincenzo Tursi and I'm partner manager at Knime. And I'm really happy to introduce you to our partner, Competitive Analytics. David, Michael, and Yuri today will show us how to deciphering economic indicators that drive your business. I won't take more time than this and will leave the virtual stage to David. Thank you again.
Okay, thank you, Vincenzo. Thumbs up. Can you guys hear me okay?
Yeah.
Okay, great. All right, share my screen. And let me know when you guys see the opening slide, just to verify. Yes, okay, good. So yeah, welcome to Deciphering Economic Indicators that drive your business. We're going to show you the power of Knime and how to leverage Knime to identify correlative and leading indicators. So to begin with, we're just going to give you a very quick agenda, 40 minutes, more like 35 minutes packed in. I'm going to talk about strategy, and then we're going to hand it over to Yuri, who's going to talk about modeling, and then Michael's going to handle dashboarding, and then we'll have hopefully some time for some Q&A. Very quickly about competitive analytics. I'm the CEO and founder, and Michael Ponton's director of analytics. Yuri is going to be our main feature today. He's one of our very talented analysts who's our internal Knime expert. Michael and I are also professors of predictive analytics in the MSBA program at this USCI Paul Merage School of Business. And let's see here. We going to give you a very quick overview. We have a very deep and broad swath of analytics services that we provide, full service analytics company. And we also cater to not only Fortune 500 companies, but SMBs across all industries and sectors. So just a couple of quick notes. We do not distribute slides, workflows, or dashboards. However, please email us at info@competitiveanalytics.com if you have any questions whatsoever. We're very transparent, and we'll hopefully be able to provide any comments or answers to your questions. So let me start by just giving you a little bit of a framework on strategizing, how to deal with this initiative of identifying drivers that drive your business. So why even bother to decipher economic indicators that drive your business? Well, to not do that is akin to, metaphorically, to imagine that your organization is on a deserted island. You're acting like you're off the grid with no influence from the outside world. And we know that this is a very foolhardy and myopic stance. So what you need to do is imagine your organization as a mixing board to the outside world. Your objective is to literally decipher the outside world's signals versus noise. So how to do that? So I'm going to go through a strategic blueprint, if you will, that bridges your internal organization with the outside world. Okay, here are the steps, essentially. Number one, you need to understand and envision your organization's strategy and tactics, both long-term and short-term goals and objectives. Think of this as a forest and the trees. Number two, you want to understand specific use cases. Whatever you're working on, you need to really understand what it is your analysis is going to bring forth. Three, you need to identify data sources, whether they're public, private. You need to identify what are the data sources that have the data that potentially might correlate with your organization's KPIs. And then you have to build an automation process, right, for the data updating itself, whether that's downloading files, an API access, or web scraping. Usually and typically, it's all some kind of a combination of all three. And then arguably 80% of any analytics project or initiative is preparing the data preparation. I think we all understand this intimately. Number six, you can start to begin to correlate KPIs with your external data. This is obviously primer to most people here, but the three major correlative buckets are positive correlation, negative correlation, and nil correlation. However, it's important to understand that all three buckets are critical in understanding how your EPIs, your external performance indicators, fall into which bucket. We'll get to that in a moment. 7, you need to calculate lead lag timing. Okay, so deciphering a KPI cycle and the EPI cycle, again, EPI is our acronym for external performance indicator, is absolutely vital. Imagine you have a KPI time series that looks like this, and you have an EPI that perhaps behaves like that. You really need to understand and identify which are coincident, which are lagging, and which, of course, the most important, are leading. We have internally a 17-phase cycle, whether it's for business, the economy, or for a product or a division or an organization as a whole. You could form your own, but what's important is identifying the different phases of a cycle, since nearly every single time series has and behaves like some cycle. So you need to understand where the stabilized equilibrium is, where your peaks are, where your troughs are, how long one complete cycle is, and then being able to classify and categorize specific cycle phases, if you will. This is an actual anonymized client example where this month, literally, they're in phase 6.8. So again, this is important because not only do you need to do this for your KPI, you need to do this for your EPI. Number 8, you need to rank your indicators. This is an example of correlating a number of macro drivers with total widget sales, year-over-year percentage growth, 12-month moving average. Again, an anonymized real client example here. But here would be a ranking of the positive correlative drivers, starting with as high as 83.77%. And then you have negatively correlative drivers, just as important as positively correlated drivers. And then you need to understand and identify what are your non-correlative drivers. These are very, very important as well, because you have to deal with internal politics and other subjective hurdles that a data science must go through. So again, selecting indicators, fairly important. And as I just mentioned, there are a number of different issues. Here are 3 that I just wanted to quickly go over. The latter and the former here being correlative versus causation and political considerations. When we look at correlation versus causation, there's a number of metaphors and analogs, but here's one that I enjoy because it's very simple. The sun may have a high causation with people consuming ice cream and a high causation of sunburn, but yet the issue for the data scientist is there a correlation between ice cream and sunburn? So you could relate this to any number of internal and external time series that you'll be analyzing for your company. The political ramifications of this are not to be ignored. And this is actually a true story. We had analyzed LIBOR rates because the client was in love with using LIBOR rates as a projection, as a pulse to their market. And so we had analyzed LIBOR rates to the nth degree and realized that they do not correlate to any KPI for any time period, for any interval going back 100 years. But that still didn't matter because the CEO just absolutely was convinced that LIBOR rates were something that he needs to use to project his business because he's been using it for 30 years. So a lot of times when you're correlating drivers and reporting the results, there is a sensitive number of issues that you need to be aware of when you're communicating this. So anyways, number 10, we're going to do some modeling, and Yuri Stickney in a moment is going to go through this Knime workflow, which provides the calculations and identification of those macro drivers. And then after that, there's a number of other things that you'll need to do. Not going to go over that today, but there's ensemble modeling, multi-modeling approach, meaning don't get stuck with just building one model, dashboard and distributing. And Michael Ponton is going to go through his series of dashboards, which take the results from the Knime model and bring it into a visual platform. Here we're using Tableau. And then, of course, the last 3 items are diagnosing your analytics, doing some predictive analytics. We don't have time to go through this platform, but this is a holistic ensemble modeling platform that we use. And then there is the prescription, meaning you've got to, at the end of the day, tell your decision makers what they should be doing, and then actually following and hopefully driving the decisions that are made by the executive staff. And then, of course, there's a feedback loop, which is shown here. So here are the 16 drivers that I just very quickly went over. Apologize for going through this very quickly, but we want to get to the good stuff. And so now I'm going to turn it over to Yuri, who's going to go through modeling. And then after that, we'll listen to Michael show you the dashboard results. Yuri?
All right, I'll go ahead and share my screen. Okay. So what I have here is a Knime workflow, which utilizes the group loop start tool to run hundreds and potentially thousands of linear regression models. And as David was mentioning earlier, this model is based on external and internal KPIs versus EPIs. So over here on the left, I have two simple file reader tools, and this is where I'm reading in my target or KPI variables. So here on the top one, I'm reading in my KPI. There's two in here, XYZ and XYZ year over year, which is just the year over year variant of XYZ. And then I have the date and the target, which is our value, which we're trying to model. Now on the bottom side, I have our external indicators. These are all macroeconomic indicators, which we've gathered from the FRED. Here I have the series ID, bucket, which I've assigned, and the title of each series, along with the predictor or the value and the date. And as you can see, there are quite a number of records in here. And if we look here in the group by, we can see that there's 568 different indicators. Now this is a subset, and in practice, I would have thousands, if not tens of thousands of indicators here. After reading in the files, I do a bit of cleanup. The dates are being read in as strings, so I'm using this string to date time tool just to convert those strings into dates. Both sides, I'm just doing that. So as you can see, it's a date. Next, I'm gonna get into this red box here, where I'm doing a bit of feature engineering or variable engineering to create the lead and lag variations of our predictor or external indicators. Now, essentially, as David mentioned, the purpose of this is to tell whether if an indicator were to be shifted over or forwards, would it correlate better with our target variable? Now, the way we're doing this, or the way I'm doing this here, is using the date and time shift tool. And I'm just subtracting 1 month from the date, effectively shifting over all of the values back 1 month. And so by doing this, we can tell if our EPI were shifted back 1 month, would it correlate better? Does it actually lead our KPI? And in practice, I would have many more variations of this or these series of tools here. This is just one example, but in practice, I may have -2 month, -3 month, all the way up until -24 months to capture 2 years of lead or lag. And essentially, I would have 24 of this set of tools here. And after shifting the date, I'm just using a bit of string manipulation to add the -1 month onto the series and the title to just label these as their own indicators, as you can see. And then I just use the concatenate tool to union these results onto the original data set. And as you can tell, have 296 here, and this should be double 592. Okay. So at this point, I can join on my external indicators onto my internal or KPI target metrics. And I do this by using the joiner tool. And I am just joining on date. So by doing this, it will create a mapping between the target variable and our predictors wherever they join on date. And I'm using an inner join. So this will effectively create a one-to-one mapping between each KPI and each predictor variable. Furthermore, I label each combination using string manipulation. I'm just combining the predictor series ID along with the title of the predictor and the target. So this is going to be a unique key for each target predictor pair. And you can tell using this group by here that we have 2,260 different combinations between our KPIs and our EPIs. And this key that I've created here is what we're going to be looping on. So essentially, it's going to run a linear regression model on each combination between our KPI or our target variable and our predictor. So at this point, I will get into using this loop functionality within Knime. And this group loop start, essentially, I just select that key, which I've just created, and it's going to run all these tools in between the loop start and the loop end on each pair or each key. So it's going to run iterations of these tools on each different unique key that I've created. So the first thing I do within the loop is creating the linear regression model using the linear regression learner tool. And how I have this configured, I just select the predictor variable here as our variable, and then the target is our target column, just like so. And if I look at the output, the second output, it'll show us all of our standard linear regression coefficients and statistics. So standard error, t-value, p-value. Now, the only thing I really care about here is the coefficient for the predictor, as we'll explain later. But I just need to isolate this value here. And so I'll just skip over to this sort of light brownish box here, where I'm just using a column filter to filter on that column, the coefficient column. And you can see, so there's our filtered column. And as I said, I only really care about this first value here. So I use the row filter to isolate the first row using include rows by number. That gives us that. Now, next, I want to calculate the R squared. And by doing, to do this, I will use the regression predictor, which will score our model with the predictor. And so if I look at the output here, it's added a prediction column. And essentially, it's just trying to predict the target using the predictor with the model that was created here. And so there's our prediction. And I just feed that straight into a numeric scorer tool, selecting the target as our reference and the predicted as our predicted column. And by running this tool, it will automatically calculate our R squared value, along with some other standard error metrics like mean absolute error root mean squared error. These are sort of standards, but we just care about the R squared here. And so I use the row filter just as above to filter down onto the first row, isolating that one. And I just do a bit of renaming since it's named prediction target. So just to clean this up, I use the column rename to change that to R squared. So at this point, I'm just going to append on those two values, the coefficient and the R squared, onto our original predicted data. And to do this, I use the table column to variable tool along with the variable to table column tool. And this effectively converts this cell into a variable, and I can then append that, or it'll just tack it onto the end of our table. So if I look here at the output of our first one, you can see there's our coefficient. And this is just for our first, just one iteration. So you'll see that there's only one series, one title. And it'll do this for every single combination between target and predictor. And so, yeah, as you can see, it's just named row 1. So I do a bit of cleanup here as well. Column rename. So just rename that to coefficient. And then the same thing goes with the R squared. And if I look at the output here, you'll see the R squared from earlier. And that's essentially all I want, just these two to sort of rank our EPI and how correlative it is to our target variable. So at this point, I can end our loop, put a loop end, and I'll just go ahead and run this so you can see how this looks when it's running. So as you can see, it's going pretty quick, running these linear regressions. Yeah, Knime does a good job with these machine learning models. And almost there. And there we go. All right, and at this point, now each pair between target and external indicator has our coefficient, our R squared, in the prediction column. We can now use a group by. I'm just gonna group on the target predictor key along with the R squared value. Go ahead and run that. And then I'll just sort it by the R squared in descending order. That way we can see which ones correlate the best. And just like that, we can tell that banks here, in this case, mind you, this is a subset, that correlates best with XYZ with a 0.805 R squared with the 1 month lead variation. At this point, I can write this out to Tableau, and I'll hand this off to our Director of Analytics, Michael Ponton, to show you our results in Tableau.
Thank you, Yuri. I'll share my screen here and show you some dashboards. Okay. So the ultimate goal of this process here is to ultimately build a predictive model with, say, a handful of indicators that correlate with your target variable, or what you're trying to predict. The first step of that is running through what Yuri just showed you, was just overlaying, thousands, tens of thousands of indicators with your target variable to see what correlates, and even more importantly, what leads as well. So once Yuri's generated all that data, we put it in a Tableau for visualization, and then we start our selection process. So this dashboard has a few elements to it. The top half is just a simple line chart with our target variable in red. In this case, it's the year-over-year growth of our sales, whatever product we're selling. And then the macroeconomic indicator is in black. And in this case, we're looking at real final sales to private domestic purchasers. And you can see the correlation there. Down below, we have a list of all the indicators that we run through the model. Right? And this table has some metrics in it, and it also acts as a filter for us to kind of pick through different indicators. So for example, if I click on personal consumer expenditures, the chart will filter, and we can analyze personal consumer expenditures versus our year-over-year sales. But let me click back to real final sales. This table also has a couple key metrics in it. So we are looking at the calculation of the economic indicator we're looking at is actually a growth calculation. So it's a year-over-year percentage growth of that metric. It's a quarterly indicator, so that's released quarterly. It has a positive correlation with our sales. Its correlation rank is 1, so it ranked number 1 out of all the indicators we're looking at. It has a lead month time of 11 months. And so what happens with this indicator, say this indicator goes up 1%, 11 months later, it'll affect our sales by X%, whatever the coefficient is. It has a R squared at 11-month lead time of 85%, which is really good. And it has a coefficient of 5.667, which we'll get into this in a little bit. Now, to illustrate the lead time here of 11 months, we create a parameter in Tableau that shifts the economic indicator over to line it up with our year-over-year sales. So what Yuri's model is essentially doing is running a correlation between the red and black line, then shifting it over 1 month, running that correlation again, shifting it over another month, running it again, and so on, up to maybe 24 or 36 times, depending on the data. And in this case, it says 11 is the optimum lead. And you can argue that it's either 10 or 11. And this is where, human judgment comes into play. And you can see how lockstep these lines are now versus before, where you can clearly tell that the black line's leading the red line. We also have some other filters in here. We could filter on the driver bucket depending on what industry that metric resides in. So it's automobile industry, or housing, government, and so on and so forth. We have some other correlation filters. So if we only want to see positive correlated filters or negative correlated metrics, we can do that. We have a lead month filter. So say we want to filter out anything that has a lead time of less than 6 months. So we really only want to see indicators that lead at least 6 months. We can do that. We can look at certain frequency drivers, so daily, monthly drivers, quarterly drivers, so on. And then we have a filter, correlation filter as well. So if we only want to see indicators that say have at least a 75% R squared, we can do that quickly and narrow it down to just a handful of indicators that correlate well. So once we go through the process of isolating the indicators we want to use in our model, which is both an art and a science, we build our forecast model. And I'll switch over to an example of that. So this is a forecast model that is driven off 5 economic indicators for our product, for our sales, for product A. Now this model you'll see has a couple, several elements across the top here. We have a primer, the driver definition. So the drivers that we did use, what are the definitions of those drivers? What do they mean? And then our summaries for each one of these drivers. Right now we're on driver 3. And so you can see its history there with a couple main benchmarks. So we have the historical min for that indicator, the historical median, and the historical max, just to give some context. And then we have a forecast here. So in order to generate a forecast for our product sales, we first have to generate a forecast for these economic indicators. So what we do is provide a set of forecasts from conservative to aggressive. And right now it's on our moderate or recommended forecast. And you could switch that. So our clients can toggle between these different scenarios to generate, a really infinite what if scenario. So if I click on conservative, you'll see these dots here shift down to a much more conservative scenario. We also give the user the ability to generate their own scenario. So if you click user, they can come in here and actually type in this case, quarterly, what they think that metric is going to be. So they can generate their own what if scenario. I'll put this back to moderate. In this model, we also provide another overlay chart. So this is very similar to the previous dashboard. It has our sales in red and the macroeconomic indicator in black, but it's narrowed down to just the 5 we're using in this model. So I can click on, for example, driver 4 that's in this model. And this is actually a negatively correlated driver, which you can clearly see. I'll switch back to here. And with this, it also has an interpretation of what that coefficient means. So this coefficient here that Yuri's model is outputting right here is really how the drivers relate to each other. So for example, if I go back here, we can see a 1% increase in gross savings as a percentage of national income, so the black line, will result 4 months later in a 2.21% increase in our sales. So it interprets that coefficient for it. We also include a correlation matrix, which is probably familiar to several of the viewers, where we have the target variable and the predictor variables on the X and Y axes, and then provide a matrix that has correlations of every indicator to every other indicator. So for example, product A sales versus product A sales, they're the perfect correlation. Our sales versus real potential gross domestic product have a 0.849 correlation, to total non-farm employment, 0.6, and so on. And then finally, we have our forecast. So again, the red line representing our actual historical year-over-year percentage sales. The gray line is the modeled value. So based on these 5 indicators and their value at that time for, say, in December 1997, this is what sales should have been. So it's our predicted value. And if I toggle back to the workflow really quick, this regression predictor tool, that's what that outputs. So this prediction target here, this column, is those values. And then finally, we have in light red, we have our forecast. And you can see, this is the, due to COVID here, which is, results in some crazy year-over-year percentage growth numbers. But we also provide up above these drop downs, again, that toggle between the scenarios for economic indicators. So if we want to see, say, total construction spending, we think that's going to be a little bit more aggressive. We can click aggressive, and this red line here is going to shift up. So it gives the user the ability to generate as many scenarios as they'd like on the fly. And just to summarize, what we usually do is just summarize our findings and say a forecast summary, which includes like the aggregate units, the historical, say annual look, annual values, annual totals, and then the forecast and say light gray, and then all the various scenarios in the different colors to show you just the range of possibilities. And with that, we have about 3 minutes left. So I guess I'll just open it up to Q&A or hand that back to David.
Okay, yeah, we have about 2.5 minutes. So I'm looking over at the questions here. We've got 2 questions that focus on Jupyter Notebooks. What are the advantages of using the platform? I'm assuming the platform meaning Knime versus Jupyter Notebook. So, you're talking about an open source solution versus a self-serve solution, essentially. That's a really difficult question to just summarize very quickly in the time that we have. I would say that, Knime is a solution that's already been proven out. There are workflows, thousands of them out there that have actually proven to work, whereas the open source platform is more of a compilation of Lego pieces, metaphorically speaking. There's probably a lot of strengths and weaknesses for both. It's a harder nut to crack right now. I will say though that the Knime platform is a more readily accessible, more power right out of the gate, if you will, to be able to structure from some very fundamental to some intermediate level workflows. That's at least our perception of it. That's probably more qualitative than quantitative. I'm sure there are some out there that might feel otherwise, but just from our take. The next question we have is, have you thought about creating and sharing on the Knime Hub a component for the date shifted feature creation? That part of the workflow looks super useful and reusable. Yes, absolutely. We're working with our Knime partners to understand, we're relatively new partners, so we're understanding ourselves the Knime Hub and what it is we can participate. We have a lot of plans to do that. We unfortunately, or fortunately, depending upon how you look at it, have been just super busy with client work. I think at the beginning of COVID, we were wondering if we were not going to be busy, but it was actually the reverse. It doesn't look like we have any other questions, so maybe we can wait a minute or two for anybody that wants to stay after, but I think we're literally 18 seconds after our time allotment, so I can hand it back to Vincenzo and want to thank everyone who attended the seminar. I don't see you, but I know you're there, so thank you very much.
Thanks,
Thank
everyone.
you. Thank you, David, Yuri, and Michael for this interesting presentation. And thank you everyone also for attending the breakout session. Looking forward to see you tomorrow again.
Thank you, guys.
Thanks.
Take care.
Be safe, be
Yeah.
well. Thanks.